Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're on Zoom joining us, just look at the top of the bottom of your screen, wherever your Zoom controls are, just click on the Q&A button that you'll find up there, and it'll open a new window. You can type in your question, hit submit, and I'll get to those questions at the end of the session. If you're joining us live on YouTube, just make sure to use the live chat function, wherever that happens to be on your screen, and I'll get to those questions at the end of the session as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 8 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I worked in the dealership, and over time, I guess, became that diag guy in the shop that always seemed to get those weird cars that no one else could seem to figure out. So the intermittent problems, the drivability problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. It's been a little over 25 years under hood experience for me. So our topic today is diesel emission systems. So this class is going to give you a good overview of the different systems that they're using nowadays to control emissions on diesel vehicles. This will be really good if you're more of a gasoline type person and you don't really work on the diesels too much. Maybe you're not familiar with them. And also, even if you are a seasoned diesel professional, you still might get some tips and tricks out of this as well. Just kind of help you with some of the diagnosis, especially on those NOx sensors. So we'll get to that towards the end. So let's talk about controlling diesel emissions. If we look on this big truck on the right-hand side there, you can see it's belching the black smoke. And really the EPA wants to minimize that, right? We want to have less harmful emissions going into the atmosphere, so it's a little bit easier to breathe and all that stuff. So starting not all that long ago, honestly, it's less than 20 years ago, they started adding more and more emissions controls on the vehicle. And then I know they had different emissions levels to meet at different years. So 2007 had one, 2010, and so on. So they affect the emissions in different ways. Now, if we think about what they did in the automotive world back in the 80s, they use a lot of the same techniques with the diesel trucks nowadays. Now, we're not focusing really on the big rigs with this one. It's more of the F350s, F250s, that sort of size vehicle. But they do use similar types of emission controls. It doesn't really matter how big it is. It still uses, there's a lot of commonality between the two. So first off, combustion chamber design, right? So how do they control it in the combustion chamber where the combustion is happening? So they maximize swirl in the combustion chamber in order to mix that air and fuel better. They have to balance this with the pumping losses associated with the higher swirl, and they try to find that happy medium in there. So the engineers work on getting that combustion chamber the right shape and everything to try and get that to work. They also, with the fuel atomization, they inject fuel at a higher pressure, and they have multiple injection pulses and more spray holes in the nozzle. This will increase the surface area of the injected fuel by finely atomizing it. Allows us to have more surface area to have a better combustion. They also retard the timing when they talk about ignition timing. That helps reduce NOx, and they would advance it to reduce soot. So they have to get in that happy medium there again. So retarding the timing reduces NOx emissions. Advancing it reduces soot. They add EGR, exhaust gas recirculation, to reduce NOx emissions as well. There are a couple caveats to that and a couple disadvantages to that, so we try to offset. And also more closely control the boost pressure to reduce soot on accelerations. That deals with the variable geometry turbos that we see on a lot of these diesel vehicles as well. And then, of course, they want to regulate the engine temperature, compression ratio, and more, just like they would on a gasoline engine, trying to regulate the emissions on that. You see that, like, especially with the EGR and the timing and the fuel atomization. We talked about that last week with GDR, a couple weeks ago with GDI. So definitely a lot of strategies that they can use. After the combustion chamber, that's where we get into the big exhaust pipes, the exhaust oxidation catalyst, the diesel particulate filters, and the selective catalyst reduction. So we'll talk about those three components as we go as well. So this is just kind of an overview picture here. of the different systems that they use and kind of where they fall in the chain here. So we have our EGR valve right here, which has the air, and it also has recirculated exhaust gases go through there. Now to cool off those hot exhaust gases, we have an EGR cooler that cools off that charge air as well, goes in through and into the back into the intake to lessen the temperatures in there. There's our variable geometry turbo right there, right? So that'll change the trim level of the fins on the turbo to change boost levels there. And then it goes through, and then it goes into this diesel oxidation catalyst, which works very similar to a gasoline engine catalytic converter. In this case, the DPF is first. Some vehicles, the SCR is first. It can be either way, but they do the same thing. So the DPF catches the soot, tries to catch the soot coming through the exhaust there. It's also a differential pressure sensor in there. We're going to talk about that. NOx sensor, multiple NOx sensors in there. Needs to be at least 2. Sometimes there's more to calculate how much of those oxides of nitrogen that are in there. So those are the bad emissions that we want to try and control. And then we come down a little bit further down the line and we get into our SCR and DEF system. So DEF stands for diesel exhaust fluid. And we can see the components of that down here. We got the tank that holds it. We have a heater in there. We have a pump, some lines. And then we have this injector right here that goes in and injects that solution into the exhaust, gets mixed around a little bit, creates some turbulence. And it goes into the SCR system, which is our selective catalyst reduction system. Then it goes into AOC, which is an aftercat. And then there's another NOx sensor on the other side in order to see, is the SCR system processing that NOx emissions out of the exhaust stream. Also see multiple temperature sensors in there. And as I said, we'll drill down a little bit more as we progress through the presentation. I just wanted to kind of give you that overview and see where everybody kind of sits in the grand scheme of things, right? So diesel EGR in the combustion chamber is where we're going to see this. And it slows combustion to help NOx from being generated. So higher cylinder temps help us create more NOx. We want to lower the combustion temps and by putting that exhaust gas in there. So it adds an inert gas in the form of the CO2 that's in the combustion gas. Slows down that rate of combustion. Thing about diesel EGR, though, is it needs the cooler too. So it needs to cool that exhaust gas coming in. And the diesel exhaust itself is full of, well, some crud, right? It's got a lot of soot and other things before it gets processed. So you can gum up the works as well. So it's very abrasive, can wear out engines prematurely. So there's a fine balancing act they need to use, the manufacturers need to use to try and get this right. Using variable geometry turbos, raise the exhaust back pressure, which makes the exhaust flow into the intake under low boost as well. So here's just an example of an EGR valve that we got a bunch of soot and oil and a bunch of crud in there. It kind of gums up the works. It's a mechanical valve, right? It opens and closes. It's electrically controlled, but it opens and closes like a stepper motor. So if I have gunk in there and it really gets into that valve, it's going to not allow it to open and close the way it should. It could cause some extra mechanical resistance in there, could burn it out. There's just another view from the inside without that cage that was on there. So we can see all that gunk in there. So, that can also cause issues inside the cooler as well with that, where it clogs up the works and we don't have as much flow, right? Can reduce that flow. So after we're done in the combustion chamber, then we need to get into the exhaust. So after combustion, we talk about exhaust after treatment. So how do we treat the exhaust after the case? So we have the diesel oxidation catalyst, which is the first thing in line. Then we have the diesel particulate filter, multiple exhaust temp sensors, DPF back pressure sensor, which tells the computer how that diesel particulate filter is operating, and also a hydrocarbon dosing valve in there as well. So first off, we have the diesel oxidation catalyst that's usually closest to the engine, converts hydrocarbons, oxidizes dosed fuel during active regens as well. So we're actually going to spray fuel into the exhaust to heat up the diesel particulate filter, and it helps oxidize that, and converts NO to NO2, which helps us in that oxides and nitrogens used during passive DPF regeneration for that. So there's a lot of hydrocarbons in a diesel fuel to begin with, and especially any unburned hydrocarbons that would come out through that as well. Then after that, we get to the diesel particulate filter. So the diesel particulate filter has 3 jobs. Well, really 2 jobs. It's going to capture that soot. It's the soot that's in the exhaust, and then it's going to store it. And then once it's full, we need to clean it. So it's really capture, store, and clean. Now, wouldn't it be nice if we could have these little elves in there, but that's pretty high temperature working conditions for those elves, right? So it's going to catch it, it's going to store it, and then when we need to clean it, we need to burn it, right? So obviously not the scale there, but you kind of might get the gist that we're going to store it, right? So it works through this substrate here. It's going to be a flow through the wall. So you see how every other hole in there is plugged up. So that doesn't allow flow through there. It allows flow through the open holes. When it flows through an open hole, it's going to catch that soot on the way through, and it's able to flow out through the open holes. That way, if it does clog, it's not 100% fully clogged, and we can still have a little bit of flow there through the sidewalls as well. Now, over time, especially if we don't regen when we need to do so, this is a vehicle that they didn't regen. So it's full of soot, clogged all up, and that's going to have to be replaced because I don't think you're going to be able to burn all that soot out of there. But you can see how it clogs up. We got it on the outside. We got it clogged and coming out the front. You know, that is full of soot. So in order to clean the soot out, we do need to do that regen that we've been mentioning. So there's 3 different ways we can do that. So we have a passive regen. So that happens when the DPF temps are high enough to burn the soot from the DPF without needing to add any extra fuel. So that'll happen only under high load condition. It'll just get hot enough and it'll be able to burn it off, right? That's part of normal operation. Active regens can be initiated by the PCM during normal operation, as long as it's going at a meets certain parameters, or by a scan tool. You can actually force an active regen with a scan tool on some vehicles as well. When this active regen happens, it doses extra fuel into the exhaust, which raises the temperatures inside that diesel particulate filter to approximately 1,025 degrees Fahrenheit, give or take, around about 1,000 degrees. Or we have a parked regen, which can happen as well. So that could be initiated by a dashboard switch. You may have seen a switch in there to be able to do that. Or also you can initiate a parked regen with a scan tool on some vehicles as well, as long as the manufacturer accepts that as a use case as well. So it is used when attempts at active regens don't work. If you continue driving a truck that needs a regen and you don't do a regen on it, over time it'll slowly derate. Eventually you go through a few stages and then it gets to the point where it's in a limp mode. It won't go over like 10 miles an hour. And then you really need to do one of those regens pretty quick. And it's going to be a parked regen at that point because you can't drive the vehicle fast enough to get that active regen going. So there are ways we can do this. And then eventually it's going to get to the point where it's so clogged, you got to replace it. All right, so you definitely want to make sure that the regens get done as well. We can also have too high a temperature in there and we can get melting. So here is just an example of a melted cat. You can see how the flow and all the melt is over here. And then the substrate's kind of broken over there and it just kind of melts and that needs replacement. Or it can break. Just like an gasoline catalytic converter, we can have breakage, we can have melting, we can have all sorts of other issues in there as well. So that would definitely need a replacement as well. You can see the pieces that's just kind of sitting in there crumbled, and you can see how it's kind of clogged up too. How does the computer know that the DPF is working or how well it's working, and how can we diagnose the system with this? So for one line of defense is going to be our exhaust gas temperature sensors. That allows the PCM to monitor the process. So how hot's the exhaust going in? How hot's the exhaust right before the DPF? How hot is the exhaust after the DPF? And based on tables and calculations inside the PCM, it can calculate whether or not that DPF lit off and was able to burn. Also used in conjunction with a differential pressure sensor. So what this does, it has 2 lines. One's before the DPF, one's after the DPF, and it can measure the difference in exhaust pressure before it and after it. So if the pressure changes the way it's supposed to, then it's working. If the pressure doesn't changes, or if the pressure is way too low on the back, then it knows it's clogged and needs a regen. All right, so based on the logic of the computer, and these are all things that can be tested, and they can fail as well. And then also the dosing valve is involved with that too. Remember how I said we inject fuel into the exhaust which allows us to light off that DPF at the time. So that's just an example of one of those dosers. Adds diesel fuel right before the oxidation catalyst. When the fuel hits the catalyst, it's going to light up the fuel. It's going to increase the temperature in the exhaust and warms that DPF enough to regen the soot. It's plumbed into a diesel fuel line, so we'll use diesel fuel out of the tank for this, and then works in the active or parked regens. Some also have air plumbed into them as well to better atomize the fuel. So how does the PCM determine what that vehicle needs or whether it needs a regen? So use that differential pressure sensor like we said before. Some vehicles may even have a wideband oxygen sensor in there to measure the oxygen content in the exhaust. It'll calculate based on distance traveled, engine speed, engine load, air mass, engine temperatures, and exhaust gas temperatures as well in multiple sections of the exhaust system. So if we look at this, it's kind of a complete exhaust system with sensors. So you see there's that hydrocarbon injectors before the cat. So that's where it's going to dose the diesel fuel. We got our DEF injector and our SCR, which we're going to talk about in a minute or two. So that's where it sprays it in there in between. Going to have our differential pressure sensor. As I said, we got a line before the DPF and after. We have four exhaust gas temperature sensors on this particular vehicle. So we got one there, before and after the cat, and then before and after the DPF. We have NOx sensors on there as well. So not NOx sensors, NOx sensors. I know when I speak, it might not come out quite the same, but a NOx sensor. So we have one going in and one coming out after the SCR, because that's what processes the NOx in the engine as well. Could be more than two, depending on the vehicle. And then, of course, all these different sensors can fail. One can fail, multiple can fail. The computer can read them wrong. We'll talk about that in a little bit as well. So if any of those sensors fail, they do need to be tested. They need to be replaced. Oftentimes there are relearns and resets available for those as well. We'll talk about that when we go live on the tool. So it's a big, complex animal when it comes to trying to control these emissions when it comes to the exhaust system on these vehicles. So here's just another look talking about the different sensors on there and talking about the exhaust gas temperature sensors there. So we see the exhaust gas coming out of the engine relatively cooler, comparatively speaking, than the one we're doing a regen. So we have a temperature sensor here going in before the cat. There's my injector. It's going to inject in light. It's going to heat up the exhaust. Temperature sensor going in, temperature sensor going out. Computer takes all that into consideration and decides whether or not that regen was successful and whether or not it's even working, whether or not it's even flowing properly, right? So we have multiple temperature sensors, multiple NOx sensors, and that brings me to this SCR system. So selective catalytic reduction is what SCR stands for, and that reduces NOx after formation in there. So it uses diesel exhaust fluid. You've probably seen those, the blue jugs that go, or the actually gas station down from my house has a pump, but that goes in the blue tank, the blue cap on the truck there. It's a third urea and 2/3 water, so it mixes together. ECU controls the injection. The injectors can clog. The injectors can freeze and gum up. We could have problems there. 1 gallon of urea treats about 100 gallons of diesel fuel. EGR, we talked about that before, gives us a 2% decline in the fuel economy due to the exhaust temps being a little bit lower. But the SCR gives us back a 2% to 5% increase in fuel economy. So that's another one of those balancing acts, right? So it allows us to return to normal injection timing, which helps restore the fuel miles. So we took it away at the front. We can give it back at the back. And it's just that balancing act to try and balance out fuel economy versus emissions. Just like back in the day, early on gasoline engines, when they first started putting cats on there, was a balancing act. And it's still a balancing act even today with gasoline direct injection. But they're using a lot of the same type of things. But diesel is a lot dirtier inherently. So we need to have a lot more stuff attached to the engine in order to do that. So things like the SCR catalyst itself, a decomposition tube, which is where the DEF gets injected with the DEF injector. We also have the pump tank and lines to feed it, as well as the heater systems, NOx sensors, which sense oxides of nitrogen, and then ammonia sensors on some vehicles. And we'll see where that could be an advantage in a minute. Here's an example of that decomposition tube. So this is on a Cummins, so you might find that on a Dodge. The dosing valve is in there, so that's where it injects the DEF fluid into this decomposition reactor. So that's a space that allows blending of the DPF with the exhaust stream. Most often it has some type of blending vanes in there as well to increase swirl. Also where the DEF accumulates when the injector fails. So if I have a failed DEF injector, it's going to accumulate in here if it says dripping, leaking. Or when the system is operated at low temps for extended periods, it might not light off and burn all of that either. So it'll collect in here. So you might find some collected DEF in there if you have a problem. Here's just an example of a DEF injector. You see it kind of works, kind of looks a lot like a top feed gasoline fuel injector, which for all intents and purposes, that's what it is. A top feed, top fed injector. See the fluid goes in here. And we got an electrical connector in there, and it's a solenoid opens and closes. Works very much akin to fuel injector. And then we have, where it mounts to the actual chamber. It's got a couple heat sinks there, so it doesn't get too hot and the like. But that's just one example of what that might look like out there. We could test it. It's got electrical connectors on there. And then we have a lot of other plumbing issues there. So we got the tank, we got the lines, we got the pump. Pump could fail, could have leaky lines. Coolant heater circuits fail a lot. Level sensors in there could fail as well. So a lot of failure components in the system. The injector could fail. All sorts of different things we could fail. So we need to be able to test these on the vehicle. Then we have the NOx sensors. So you see that's a very fancy looking sensor right there. It's got a whole computer chip board on there and everything. That's pretty fancy. There's at least two on each one of these vehicles. So we got to take that into consideration. Determines the inlet and outlet readings of the NOx emissions. Can be used in open or closed loop systems, and it can mis-ID ammonia as NOx. So keep that in mind as we go forward here. We're going to talk a little bit more about that in a minute. But these are prone to mis-IDing ammonia as being NOx. So that can cause some issues when we're diagnosing it. To combat that, some vehicles have an ammonia sensor on the vehicles to be able to sense ammonia in the system. Measures the ammonia levels after the SCR happens. Allows much greater NOx regulation because we won't get lied to by the NOx sensor. The computer can take this into consideration and judge how much is NOx and how much is ammonia. And it is immune to other exhaust gases. So it's there to sense ammonia. It's only going to sense ammonia. It's not going to be fooled by any other exhaust gases in there. So here's just one example. We saw this picture earlier. So this is a typical system with the DPF first. So the particulate filters here, and then our SCR system is here. Then if we want to go on to talk about Ford 6.7 liters or the Duramax system, the SCR is first and over here, and then the DPF is at the back end to try and pick up all that on the end. Still have the pressure and temperature sensors, still have the NOx sensors in there. But sometimes it can be first, sometimes it can be last. It just depends on how the manufacturer set it up. But it does the same thing no matter where it is in line. These all do the same thing no matter where they're at. So let's see how it operates. So in this case, we have our different components we talked about, right? So we have our inlet NOx sensor, our outlet NOx sensor. We have our diesel oxidation catalyst in this case. We have our DPF system before the SCR system in this case. We have our injector where it injects it into that chamber where we have the increased swirl and it combines with the exhaust gases. Then it goes into the catalyst, which converts it to, gets rid of all the NOx emissions. And then in this case, this also has a little catalyst at the end to collect whatever's left at the end. In order to diagnose this properly, you can use a scan tool to diagnose it. But as I said, sometimes we can get lied to. Now, a good friend of mine always says, scanners don't lie, they get lied to. And when I saw this is a perfect example of how a scan tool can get lied to, and you might get misled down the wrong path. Not the scan tool's fault. It's actually the sensor's fault. So in order to make doubly sure that we understand what's going on and whether or not this catalyst system is working, we want to also use a throwback item. If you've been around diagnosing gasoline engines for a long time, you may have used a 5-gas analyzer in the day. They're still a great tool to have today. Maybe fell out of fashion a little bit, but for working on diesel emissions, this is an excellent tool for it because we want to see that NOx emissions and be able to measure it and check against what the computer's telling us. So here's an example. This is just warming up the vehicle. Here's our SCR system working in here. There's the injector, and here's our oxides and nitrogens going through. So if you were looking at the data on the computer on the through the scan tool, knocks in 300 parts per million, knocks out 300 parts per million because it's not doing anything right now. The injector's not spraying. It's not lighting off the catalyst, so it's not going to do anything. So by virtue of that, my 5-gas is also going to read 300 parts per million because that's truly what's going through here. Under normal operation, the NOx coming in 300 parts per million because that'll be a constant throughout these slides just because we're having the same baseline go in. The injector comes on and injects the ammonia in there with it. That all gets caught up in the SCR system and then the slip catalyst and then knocks out of 30 parts per million through my scan tool. Verify that with my 5-gas, 30 parts per million coming out the actual gas itself. Now, when we get into problems, total SCR failure. This SCR is not working whatsoever. It's failed for one reason or another. So in this case, the computer, according to the NOx sensor, sees 300 parts per million going in, as it always has. Injector's on. It's spraying additional urea into there, so we get the ammonia in there, and it's not doing anything. So that ammonia and the oxides and nitrogen are getting through, it's just going right out the back. And then according to the NOx sensor, because remember how I said that NOx sensor can sometimes misidentify ammonia as nitrogen oxides of nitrogen. So according to the computer, it's seeing 600 parts per million come out the back end, but how am I going to have 600 parts per million coming out if I have 300 going in the front? So that's where we need to verify that with my 5-gas. So I could have a bad sensor that's reading wrong, or I could have, well, the cat's not working, right? So if I misdiagnose this sensor and replace it and there was nothing wrong with it, it's just doing what it normally does and reading wrong, that could be $1,200. And if it didn't need that $1,200 NOx sensor, well, that's not a good thing, right? That'd be a misdiagnosis. We don't want that because in turn, your cat is still not working. So I could replace this sensor as many times as I want. It's still going to read 600 parts per million because the cat's not working. The SCR is not working. So the only way to verify operation is with that 5-gas, right? And then here's on a partial failure. So in this case, 300 parts per million going in. According to the sensor on the back end, it is reading 300 parts per million out. But if I read the actual exhaust gases, 150 parts per million. So it looks like it's doing half the work in that case because it's getting rid of half of the NOx. It's not getting rid of all of it, but it's partially working. It's partially not working. So in that case, we can verify that using the 5-gas. Now, if you were just to look at these numbers on the scan tool, you'd say, well, it's not working at all because it's just coming out the same as it's going in. So is my injector not working? What's going on? So that helps you to diagnose that just by looking at the exhaust gas. So like I said, really handy tool, especially when it comes to looking at diesel emissions there. So definitely worth your time to check that out. Now, I only have about half an hour or so, give or take, on these classes. So I am not able to go way in depth on this like I could, but a lot of this information, we were helped out by our friend Joe Rappa, who also worked for Snap-on. He works for Snap-on Industrial. He has a YouTube channel, and he goes way more in depth than I do on this information. So if you want more information from Joe, you can go to his channel on YouTube, youtube.com/Joe Diagnostics. Check him out. He has a lot of different diesel information. He is our diesel guru when it comes to Snap-on and training and all that. And you may have seen him at other training events. He does a lot of training for, ASA and things like that. So you may have seen him out doing trainings for other things, but he is definitely a deep well of knowledge, and he can do this way more justice, I will tell you, than I can. So definitely check him out as well for more in-depth information than I can provide for you in a half-hour class. So with that, let's go live on the tool and look at a few different things that we can talk about when it comes to these systems. So in this example, I have a 2017 Mercedes Sprinter diesel loaded. It's a couple of different things we can do in here. First off, I'd like to talk about testing sensors, testing components. So if you have a Snap-on tool with a scope, So that'd be a Zeus or a Varus or a Modus or a Triton or a Vantage. Any of those tools will have this guided component test function in there as well. Now, actually, let me back up here for a second. Hold on. I shouldn't have loaded that vehicle. So if we go into guided component test, there are built-in classes in here as well. And if we go into the how-to section of the classes that are built into the tool, there is one in here for selective catalyst reduction. I just have to find it. I don't remember how many minutes. Oh, there's a NOx accumulator class right there. NOx emissions class right there. Selective catalyst reduction class right there. So if you want more information on that, it's also available on the tool. It gives you all the chemistry that we're going to talk about with that. So I definitely don't get into the chemistry or the chemical reactions that happen in there. But if you want to understand more about that, there's a lot of information in here on the tool inside guided component tests as well. All right, so now I'll load my Sprinter. And we'll go into guided component tests. So if we go into engine system, there's over 5 million tests inside guided component tests. So I'm definitely not going to go through them all. But things like, let's see, we want to see the diesel particulate filter differential pressure sensor. So that's a DPF differential pressure sensor. We talked about that, reading the pressure on either side. So if we want to see how that works, it's a 3-wire sensor. Exhaust differential pressure sensor measures the pressure difference across the inlet and outlet of the DPF. Pressure difference across the DPF increases as captured particulates in the DPF increases. Diaphragm within the sensor is displaced by the pressure change that occurs in particulate matter loading. Sensor translates this action into electrical resistance. The engine control module supplies a 5-volt reference circuit and ground at a low reference circuit. The exhaust differential pressure sensor provides a signal voltage to the ECM relative to the back pressure as a function of exhaust flow, DPF temperature, and DPF soot loading. So we would see it's a 3-wire sensor. So we have power, ground, and a signal. Very similar to a MAP sensor. Barrel pressure sensor is a pressure sensor. So if I back up and I go to my DC voltage test, I can read a voltage out of this if I hook up to the signal and a known good ground. So it gives you a 5-volt reference. And then you would also want to use, it says, a vacuum pump. So use a hand vacuum pump. Slowly apply vacuum pressure. The voltage should vary, and it should transition smoothly as my vacuum rises and falls without any spikes or dropouts. So I want to be able to see it go up and go down nice and smooth as I apply and remove vacuum from that DPF differential pressure sensor. So that's differential pressure sensor. We also have TEP sensors, right? So the SCR in here. So we can do a DC voltage test on that. So we should see temperature at 650 degrees Fahrenheit. The voltage should be 0.9 to 1.2 volts. The signal voltage should match the following results down here, right? So it's going to change varying based on whatever the temperature is. So we should see a temperature sensor signal with that. Let's see, pressure sensors, temp sensor upstream of DPF, same type of thing. It's going to be a variable voltage depending. Boost pressure as well. So that's going to be with our variable geometry turbo. So you can see there are a lot of components in here. NOx sensor. Let's go to the NOx sensor. Right. So one is located before the SCR and one is after. Measures NOx in the exhaust gas and the oxygen concentration. This information is sent over to the SCR can. The control unit uses this information to determine the amount of DEF required. So if I have more NOx, I need to add more DEF. If I have less NOx, I need to add less DEF in there. And of course, it gives us all of these connectors that we have on there as well in order to check that. So that is just component testing. Let's switch over to my scanner and see what we can do over on the scanner. Go through a couple checks here. Okay. So on my scanner. Now, if you have a tool with Fast Track Intelligent Diagnostics with a current subscription or data plan, or a Verus Edge with current software, you would be able to get into service resets and relearns, which is a quick link to all the service resets and relearns for a vehicle. In this case, there's 31 different resets, relearns, recalibrations needed. Otherwise, if you don't have one of those tools, that's okay. You can just go into the engine system. You could go in there and do any of the resets and relearns as well. You just have to go through the whole list and find what you're looking for. So I'll go through here, though, real quick. First thing right off the bat, they give us our fast maintenance or quick maintenance stuff at the top. So if I wanted to do a regen, so if I have to force a regen on this vehicle, I can go in here. It gives me any related bulletins and functional resets. So in this case, I'm in a simulator, so I need to choose a couple things. So they have a regen while driving, which would be that active regen, and then they have a regen at standstill, which would be what I could do just sitting in the parking lot, right? So if I wanted to do a regen at standstill, once again, I'm in simulation mode. So we need to apply the parking brake, make sure we're full of oil. If oil level is too high, change the oil. Move the transmission to neutral, ensure the engine is not idle. Don't operate any pedals. Switch on the low beams, high beams, front fog lamps, and rear window heaters. We want to load the engine. Switch on the blower, maximum power, and the hood must be closed. We go through that. Regeneration can take up to 21 minutes. Engine speed will increase to approximately 2,000 RPM. The regen can be stopped at any time by turning off the ignition. So if you do need to stop for any reason, you can just turn the ignition off and it'll stop. If I hit continue, it's going to go in here and it's going to tell me I need to meet the requirements. Engine speed must be 650 to 800. Coolant temperature has to be over 140.1. And exhaust temperature needs to be greater than 392 degrees Fahrenheit. Now, of course, all that information on this screen is just dummy data just for demonstration purposes. But once all these are met, we can hit continue and it will go through the process. I'm pretty sure it won't work, or actually it'll go through and it'll complete, right? So it'll take about 20 minutes. And then once it's done, it'll tell you it's complete. May take up to 5 minutes for engine return to idle, cooling down period. It'll cool down. Hit continue, and we're done. All right, very simple procedure to force that. So that's on a Mercedes. How about a Ford? Load a 2012 Ford F350. And we'll see there's a lot of that information in there. You're going to have the same type of information in the guided component test for sure. But if we go into as far as resets and relearns and regens, we have regen right there. So in this case, same thing. It's going to pull up my bulletins, and there's our manual regen right here. So in this case, always perform the manual regen outside of the shop. You never want to do a regen in the shop, by the way. Never do a regen in the shop. Bad things will happen. You really don't want that to happen. During this procedure, the engine speed will increase for a long period of time. The exhaust gas at the tailpipe can reach temperatures of approximately, we'll call it 1,000 degrees. Pretty darn close, 930 degrees, 30 degrees Fahrenheit. Do not place flammable materials in the vicinity of the vehicle while this is going on. Don't park it on a bed of leaves. I know it's fall right now. You don't want that to happen. Vehicles equipped with a PTO or auxiliary auto control must have that disengaged before the test is initiated. Go in here, hit continue. Cooling fan will operate during the procedure. It's normal for smoke to be generated during this procedure as well. Do not operate any of the vehicle controls. Manual regen in this case, may take up to an hour. And perform this test with the hood open. Notice on the Mercedes, they wanted the hood closed. So you want to follow manufacturer's recommendations in this case. Start the engine. The test will abort if the vehicle is not in park or neutral. If the clutch is depressed, the vehicle is moving, or the brake pedal is depressed. So this is a stationary only. Don't touch it. Leave it alone in the middle of an open parking lot is basically what this boils down to. If I hit continue, it's going to go through. It's going to calculate the load, and then it will function through the test. Now, in this case, once again, we're in demo mode, so it's not going to change. But once all these 4 parameters say in range, you're good to go, and it will start, and it will do it automatically. So that's a force regen on that. And then one more, let's go through and let's just do a Duramax. Why not? So I got a 2018 Duramax right here. See what's available through that. So in this case, we have the regen again. Let's see if what kind of we have. We have a regen enable, so that'd be enabling it to do a driving, or a service regen, which will do it, will also force it parked. Outlet temp going to be more than 500 degrees. Don't want fire or burns, so we want to park the vehicle outdoors, keep people, other vehicles, combustible materials away. Don't let vehicle unattended. Do not connect any shop exhaust hoses to the tailpipe. And you don't want to have this inside anyway when you're doing it. So I wouldn't worry about the hoses, but you don't want to put the hoses on there, you're going to melt. Due to elevated engine temperature, is important to open the hood and keep the front of the vehicle in an open environment, away from any walls or buildings, in order to keep proper airflow across the radiator. Depressing the brake stops it. Selecting off exit will turn it off as well. Coolant level, oil level need to be checked. Exhaust damage can occur due to improper usage, and do not initiate service mode if non-DPF faults are present on the vehicle. Oil changes may be necessary after running this. So you continue. It should take up to 20 minutes in this case. When the idle returns to normal, that's when you know it's done. All right, so it can go on, off, and then we can stop it in the middle by hitting release control, and then it gives you the pertinent data in there as well. Once again, demo data, not going to see it. And then also in this case, we can go through, if I replace the cat, there might be a relearn that needs to be done. Diesel after treatment injectors, we might have to go through that. Reset a DPF after that. EGR sensor. Reset the NOx sensor. So there's a lot of different functions that you may need to do on a diesel vehicle with the after treatment systems. There's automated tests for the after treatment systems. I can go through and do one of those component tests for the after treatment systems. All of these systems, there's many, like I said, it's a big complex beast for it, but there is a wealth of support with the scan tool for it, also through repair information for it as well. So as I said, I only got about a half hour, 40 minutes to go through this for you. So I know I can't give this a very in-depth discussion, but hopefully we got a good overview and we got a few tips and tricks to help you test some of the problems that you might run across with some of these systems. So with that, let's talk about next week. And I need to fix my slide. So hold on one second. So next week is not this. Next week is suspension systems. All right, so next week is vehicle suspension systems, and that's the wrong screenshot, but that's okay. So next week, vehicle suspension systems, we're going to talk about electronic steering and suspension. So we'll talk about electronic steering. We'll talk about air suspension systems. We'll talk about electronic suspension systems with the ferrofluid and all that fancy stuff with electromagnets, electromagnetic fluids. We'll talk about the different ways that manufacturers are approaching electronic suspension and steering controls there. As well as how we might diagnose them and a few tips and tricks with the scan tool as well. So once again, join me all next week, 6 and 9 Eastern. If you want to join on Zoom, go to snapon.com/OT, register there. Or if you want to join us live on YouTube, the first session goes to YouTube at youtube.com/Snap-on Diagnostics. Make sure you subscribe and ring that notification bell to make sure that you are notified anytime we go live or add new content on the channel. If you're looking for any of our previous topics as well, those are also on our Snap-on Diagnostics channel on YouTube. There's 28. This is number 29 class right now. This will be up for your viewing within the hour or so whenever YouTube decides to finish processing it. So that is available. So we're up to 29 different episodes, data bus testing, ADAS, different component test functions. So definitely a lot of free training information out there for you. We try to give you as much free training as we can out there. So let's get to questions. Looks like I got a couple on Zoom. Looks like we don't have any going on YouTube right now, and that's fine. If you do have any questions on YouTube, just make sure you use the live chat to go through there. If you do have any questions on Zoom, just make sure you use that Q&A button on the top or bottom of your screen. I also want to make sure I mention before I do get to questions, my buddy Al. Remember how I said we want to give you as much free training as possible? Al does training 3 nights a week. I do training 1 night a week. So he does scan tool training. Monday's Apollo, Wednesday's Zeus, Thursday is Triton. Same time, 5 and 8 Central, 6 and 9 Eastern. Go check it out. It talks about everything from let's set up your Wi-Fi, because Wi-Fi is important for a lot of functions on vehicles nowadays, all the way through let's set up your free Snap-on Cloud account, through let's walk through Fast Track Intelligent Diagnostics, code to completion. How will this help you no matter what kind of technician you are, what level technician you are? It will save you time and effort when it comes to diagnosing a vehicle. So that's about an hour, and that's the Monday Apollo class. Then on the Wednesday and Thursday class, he goes through that hour on the tool, and then after that, about a 5-minute break or so, goes through all the scope, the meter, the guided component test functions on the tools as well. So it is about a 2-hour class those two nights. So it is a wealth of information. He goes very deep on as to what we can do with these tools and how they're going to help you as a technician be more efficient and better at your job, because that's what we all want. We want to be more efficient because time is money, right? So definitely go to snapon.com/OT if you're interested in those classes as well. So let's see. Okay, so let's go to Zoom first. I have one on YouTube. Let's see. Tom Spina says, don't have a car behind the vehicle. Yes, we don't want to have anything anywhere around the vehicle when we're doing a regen. The funny thing I think about regens is what are we doing with the DPF as we're catching the soot, right? How do we get rid of the soot? Oh, we light it on fire and we burn it out the back of the tailpipe. So I don't know. It makes the EPA happy, I guess, but I don't know how good you're doing with releasing all that soot at once instead of over time driving down the highway. But that's beyond me. So, yeah, with that, you want to make sure there's nothing flammable or meltable anywhere near that, because you got hot exhaust coming out the back. I've seen videos sometimes they shoot flames out the back. So definitely don't want to have anything that get lit on fire. All right, let's go to YouTube now. So Mr. Aficionado, good afternoon. Welcome. Thank you for attending. I see you show up a lot, so thank you for checking in. And Francisco asks on YouTube, is it better to do a regen standstill or while driving? Ideally, I believe the way the manufacturers would recommend it happen is driving down the road, so it can just happen gradually over a distance over a period of time. But when it gets to a certain point where you get into that D-rate where you can't drive fast enough to get it done, or you can't get it done, you can definitely do it at a standstill, kind of as I think they want that as more of a last resort, more than driving it down the road, right? So once it gets to a point where you can't really drive it, or it's getting to the point where it shouldn't be driven very much, that's the case with that. All right, let's see. This is a question I don't know the answer to, but I will ask your question. So Francisco also asks, I have a Isuzu NPR with a 2.8, and it has a particulate filter and an exhaust brake. The exhaust brake does not work when the particulate filter is installed. Why does the exhaust brake not work with the particulate filter installed? I'm not sure why that wouldn't work. That sounds like it's something that should work. And I'll just say from personal experience anyways, this is totally anecdotal, and I have no idea if it has any sense with the manufacturer, but I know I've driven those before for Snap-on, and I have had it had a DPF, and it had a switch for the exhaust brake to turn it on and off. So I don't know what the deal is with that, why it wouldn't work. Maybe it's an issue with the vehicle. Not 100% sure, because as I said, I've driven vehicles with both, and they both worked. So not 100% sure why that might be happening. Could be an issue with the vehicle there for sure. Let's see. There we go. So Blade's got a good guess there as well. The exhaust brake holds the exhaust valve closed, and that won't work when we're running a regen. So maybe that's why as well. But as I said, I do know I have seen that happen both ways. So maybe that's why it won't allow you to exhaust brake certain times under certain conditions. See, the answer is always in the room. So it's always good to ask the question there, because if somebody doesn't know, somebody else will probably know. So that's excellent. Thank you for that, Blade. All right, anything else? Looks like we are clear on both sides. So with that, appreciate it. Went a little over my normal time, but that's okay. It's always good to have good discussion there. So with that, thank you very much for attending. I am very glad you attended, took a little bit of time out of your busy week to come and see me. And hopefully we learned a few more tidbits about diesel emission systems and how they work, and how we can help maybe diagnose them a little bit better, a little bit easier out there. So with that, enjoy the rest of your week. Enjoy your weekend. Hopefully we'll see you next week for electronic steering and suspension. With that, have a good evening, or whatever time it is, wherever you are, and take care.